Hey people, welcome back. And this session we are going to learn about how to calculate the process capability short term. So short term process capability CP and CPK we are going to learn about the calculation and the importance of that. So CP is the most common process capability index which estimate the process is capable of producing if the process mean were to be centered between the specification limit. So CP will tell you what is the potential your process has on a short-term basis, which means what it can deliver. So the formula for CP calculation is equal to USL, which is the specification limit on the upper side, minus lower specification limit. And if you divide this by the 6 time of standard deviation, you will get the CP value. While the CPK value is the minimum value of CPKU on the upper side of specification or CPKL, which is on the lower side of specification. So we will be checking here what is the probability of meeting the specification of upper side and what's the probability of meeting the specification on the lower side. This is the way we calculate. So we can, how does exactly it works? Let's understand with a picture. Suppose I draw, this is your lower specification limit value. This line is your lower specification. Maybe I mark this as in, let's say 20, for your product dimension is 20. And you will have the upper specification value. Suppose here I am marking this and the upper specification value is 30 for the data. You assume like as this is your air conditioner at home, which is performing between 20 and 30. So you are checking the probabilities of that what are the chances my air conditioner will go less than 20 degree or what are the chances that air conditioner will go more than 30 degree. Those probabilities you'll be checking with the process capability when you are collecting just a small set of data, maybe 15, 20, 30 days of the data point you are collecting, and you are checking what the potential it has. All right. So I got my lower specification limit. I got upper specification limit. Lower specification limit is 20. Upper specification limit is 30. What I left with? As per this formula, if I calculate the CPKU, so formula for CPKU will be upper specification limit minus average value divided by 3 time of standard deviation. And CPKL will be mean value minus LSL divided by the 3 standard deviation limit. So specification we have already got. What I need the mean value from this data, which will be generating, and I would be needing the standard deviation. As I was telling in my last session, the major difference between the short term and long term is only the way you calculate standard deviation. So for short term, like as CP and CPK calculation, we use the standard deviation calculated by range method. And for the long term, when you are calculating for the PP and PPK, we use the standard deviation calculated by the deviation method. Nothing else, there is no other difference. So what we are trying to check, suppose your average value as per this data 20 and 30. So mean expected if process should be center is you will take the sum of both the values like as 20 plus 30 and you divide this by 2. So mean expected will be your 25. If your mean value is 25, then we are good. If your mean value is less than 25, then there is a higher chance that defect will be generated on the lower side. Or if the mean value is more than 25, then there is a chance then defect will be generated on the upper side of a specification. How it will work? Let me show you through the picture. Suppose here you draw a line. Assume this is your average line. Average line as of now perfectly in the center, no issue. Both the side, when you look for the data distribution, data will be distributed on the center of the line, and here is my actual distribution of the data. So we can clearly see there is a lot of difference between the maximum value and the upper specification and lowest value and the lower specification. So if there is a gap is created here, that means this is the space still we have to meet the specification. There is a very less chance of not meeting the specification or generating the defect. But some cases when value start going the outside the specification, so your process capability will come down. Like as if I see the variation is little higher and goes like this on both the side specification. So in this case, your CPK-U and CPK-L, both value will be less than expected or less than meeting the specification requirement. Both the side, because you are generating the defect both the side. In case you have one-sided specification, suppose it's a higher is better. If higher is better, so then I will look for the probability of defect on the lower side of specification, like as productivity, quality, delivery, all these values are higher is better, sales, customer satisfaction. Then I look for the defect on the lower side of specification. In case your lower is better, which means any value on the lower side is better, like as defect, return, complaints. So then I will look for the probability on the upper side of a specification. In case your value is nominal, like as neither higher is better nor lower is better, your value is supposed to be perfectly in the center, then we'll be calculating the final CPK as in CPK-U and CPK-L, whichever is the minimum, and we'll be calculating the CP value as well. Mostly in the one-sided specification, you need not to worry about the CP. You can directly calculate the CPK. If higher is better, calculate the probability on the lower side of a specification. If lower is better, calculate the probability on the upper side of a specification. I hope basic fundamentals are clear. Now let's put the data into the formula. For that, we need the data and we need the standard deviation. The important part, as I was telling, is standard deviation using the range method we have to use here. And range method is standard deviation. The formula is R bar, basically average of moving range, whatever you have, divide by the constant D2. And the D2 value, if I tell you D2 value, if I use the subgroup size as in 2, so D2 value will be 1.128. This is the D2 value which we'll be using, and we will be using the range. Let's see. Suppose, as I was telling, this is the only you are collecting the data on the day basis for the air conditioner temperature. And here is your data for last maybe couple of days. Let's pick up the data and assuming 20 days of the data you've collected. Let me generate the temperature random data maybe into decimal as well. So random between maybe let's say 21, little on the, and here I'm making as in 28 plus some random values in the decimal. And this is your temperature data for last 20 days I have now. I'm copying pasting this temperature as a value, so that value should not change. And now I will be calculating what? First thing, I have to calculate the moving range of this data if subgroup size is in 2. So 2 data set I will take together. So if I say moving range, there is no data point before first value, so I'll leave it as in blank. And here I will take first value minus second value. So the moving range between day 1 and day 2 is 1.92. I will take second value and the third value difference, then third value and the fourth value difference, and so on. This is representing the variation. As we already know that variation cannot be negative. But some of the values here, you can clearly see in the red color, they are the negative. So I have to neutralize the impact of the negative value. So what I will do, I need to convert that into the absolute value. So what I did here, I am taking the range, and before that, if I just use the word in Excel ABS, which represent the absolute, it will convert all the negative value into the positive values. And I drag this formula. Now all of my values are positive. Formula for the standard deviation is range bar by D2. So if I take the average of this range, here, if I put average value, and average range is 2.71. We already know D2 constant value for the subgroup size 2 is 1.128. And the standard deviation for my data now will be range bar by D2, which is 2.40. This standard deviation we are going to use into all of these formula. Let's see how. And then later I will confirm the same thing in the Minitab as well. So here is my average value of range. I have the D2 constant. Average value divided by the D2 constant is 2.40. And here is my data. So let's write down some values here. Here is my upper specification limit. This is my lower specification limit. Here is my standard deviation, and here is the mean value. So mean, lower specification limit and upper specification limit, we already know. We decided upper as in 30, lower as in 20. Standard deviation is this value. And the average value, we can take the average of the data, this temperature, and the average temperature, my air conditioner was maintaining around 23.68. Basic values I got all. Now if I start calculating the CP value, so CP value is equal to upper specification limit minus lower specification limit divide by 6 times of standard deviation, which is 2.40. Here I got my process capability 0.69, which is very low, less than 1, generally considered as a not a capable process, but it's all depend on what kind of process you have. You cannot compare the medical devices or aircraft or engine parts with the process when you are manufacturing the soap and the detergent, right? So probably soap and detergent, this process capability is still okay. But if you are manufacturing the aircraft part or maybe many other things as well, like a supercritical thing, so then process capability is too low. Now, if I calculate the CPK-U and CPK-L, so CPK-L formula is mean value minus LSL divided by 3 times of standard deviation, which is 0.5101. CPK-U is equal to USL minus mean divided by 3 times of standard deviation, which is 0.87, which means whichever the side the capability is low, the chances of defect on that side is high. And the minimum value of CPK-U and CPK-L is your final CPK. So my CP value as per this data is 0.69, and my CPK value, final CPK value as per this data is 0.51. Further, if you want to convert that into the Z value, so your Z value, ZUSL, is equal to 3 times of CPK. U means CPK-U. ZUSL or CPK-U is 3 times that. Same way you can convert ZLSL, which is the 3 times of CPK-L. So if I see what is my sigma level on the upper side of a specification, so 3 multiplied by CPK-U, which is 0.88. And ZLSL is the 3 multiplied by CPK-L. This is my sigma level. All right. Now, if I want to convert that into the chance or the probability, so probability converting, you already know there is an Excel formula, which is norm S dist, which will take the Z value 2.62 and convert into the percentage data may fall within the specification is 99.67. Similar way 1.53, if your Z value, then 93.70% data will fall within the specification. So what is the probability of defect? Defect is always 100% minus the probability of meeting the specification. So this is my defect probability. Now my total defect will be the sum of on the upper and the lower side of effect. 6.73. So what is my final probability or final yield here? Will be 100% minus total defect. And this final yield I can convert into the Z value or sigma level, which will be the long term. Z bench, and this is your long term value, can be converted probability in with the formula norm sin V, selecting 93.27, and here is my 1.49 is your sigma level. Now note it down, my ZLSL and ZUSL, these are the values. Final sigma, this is the values. My short term capability as in CP 0.69, and these are my CPKU and CPKL. With the same data, what I have here, with the same specification, if you want to see how the values will be in the Minitab, exactly same value you will get. Let's see how. I copied this data, pasting in the Minitab. I know my specification, so we'll go to the stat, quality tools, capability analysis, and select as a normal. Single column data is your temperature. Subgroup size we have taken in Excel as in 2, but Minitab works on n-1. So instead of 2, in Minitab I will put as in 1. In case you are calculating the range for 5 subgroup in Minitab, which means in Excel it will be called as in 6. So always Minitab work on the Excel -1. Lower specification limit 20, upper specification limit 30. In options, what are the things you want to see? Let's say I want to see the percentage data and the capability CPCPK first. That's all. Click on OK. Because we are looking, it will give you the short term and long term both. But we calculated only short term, so I will just look for the short term data, which is what is the potential I have. Now this data is generated and here is my capability. So the potential capability within what we have calculated, can we try and match with this value? Let me copy this graph and put it to the Excel and let's see. So potential capability, if I check here, my CP value is 0.69, which I have here. 0.69 is the CP value. CPL is 0.51 and CPU is 0.88, right? So CPL is 0.51, CPU is 0.88, and my final CPK will be 0.51, which is here. Want to see the percentage, like as this is the probability of defect or the final percentage. So 0.43 on the upper side and 6.3 on the lower side. The same value you can see here, that's 6.3 on the lower side and 0.43 is on the upper side. Total is 6.73 is the defect, and that's what we have got in the manual calculation as well. If you want to see the same sigma level 1.496, sorry, I can just do the edit of this process. Instead of options here, collecting the CPCPK, I will set the benchmark level. Click on OK. And here is your short-term value. Z bench is around 1.50, which is on the lower side 1.53, upper side 2.63, right? 1.50, lower side 1.53, upper side 2.63. So if I convert this into 2-digit, 1.50, you have here what? 2.63 if I go 2-digit, and this will be 1.53 on the same what value we have got in the Minitab. This is the way we calculate the short-term process capability. Thank you so much for your time today, and I will explain the long-term process capability where standard deviation will be using by using the deviation method in the next session. Thank you, people.